Okay, geometry part 2. We're looking at unit 3, parallel and perpendicular lines, homework 7, point slope form. I talked about this front page on part 1, and I want to talk about the second page for part 2. And just because there's only 3 problems I do on the back, but number 13, there's a lot to talk about. So number 9, write the equation of a line that is parallel, so it's going to have the same slope to the line 5x minus 4y equals 4, and passes through the point negative 8, 2. So what we're going to do is we're going to get y by itself over here, so we have this in slope-intercept form, so we can figure out what the slope is. You can see that I did that here. I subtracted 5x from both sides. And then I divided by negative 4. When I divide negative 5 by negative 4, it just becomes 5 divided by 4. And when I take a positive 4 divided by a negative 4, it becomes a negative 1. So here is my slope right here. So parallel, it's going to have the same slope. So I have the same slope, and I just set this up like problem number 1. Here's the point, here's the slope. I use point and slope formula. And, with the little trick that I showed in part 1, just put this minus y1 over here as a plus y1, just adding y1, because you're going to do it anyways to both sides. So might as well start off that way so you have y by itself to begin with. Makes life a little bit easier. So my slope is 5/4. X minus my first x, my only x is negative 8. So minus a negative becomes plus 8. And then I have plus my y1, which is 2. So 5/4 times x is 5/4 x. 5/4 of 8 is 10. And if you're not sure how to find that, put in parentheses 5 divided by 4, or 5/4. And then you just type in 8, because that means multiply whenever you have parentheses next to a number. So 5/4 of 8 is 10. Okay? And so I have 10, and I bring down this 2. And now I just have to put this 10 and 2 together. So my final point slope form, slope-intercept form is y equals 5/4 x plus 12. That's the equation of the line that's parallel to this line. Okay? All right. Now we're going to do one that's perpendicular. And I have here reminding you that perpendicular, the slope is going to be opposite and inverse. So I first have to figure out the line that's going to be perpendicular to. I got to figure out what that line is in slope-intercept form. So I subtract 5x from both sides. I then divide by 6, and I end up getting this as my slope-intercept form for this line. This was written in standard form. I had to translate it into slope-intercept form. So I could find the slope. Now the slope is this, and remember perpendicular means the opposite inverse. So it's going to be the opposite. It's not going to be a negative, it's going to be a positive, and it's going to be the 6 over the 5. So I have the point 10, 7, and the slope is going to be 6 over 5. So I just write my formula, and my slope is going to be 6 over 5, the opposite inverse of the original, this equation that I'm going to be perpendicular to. And my x1 I'm subtracting, so I'm subtracting 10, and my y1 7, I'm adding that. I end up getting 6/5 x minus 12. 6/5 of negative 10 is negative 12, and I add 7 to that, and I end up getting this as my perpendicular line in slope-intercept form. Number 13. We have CD is formed by these 2 points, right? And if a line T is perpendicular bisector of CD, write the linear equation for da-da-da-da. So what I did first was I figured out, and I did this on a separate sheet of paper. So I figured out the slope for that line segment CD. It actually ends on these points. So, but it's going to still be, have a slope, and it could be written in slope-intercept form. So I figured out the slope by taking my y2 minus y1 and x2 minus x1 minus a negative is a positive. So I get negative 4/12 or I get a negative 1/3. So that's my slope. And then I just took my x1 and my y1. It comes out to be an ugly fraction, and I end up, getting this as my slope, right? So it's negative 1/3, so they want perpendicular. Remember, perpendicular is the opposite inverse. So the opposite is going to be a positive, and the inverse is 3/1 or just 3. So perpendicular, opposite, inverse. Now, I got to get a point. So a point, and this is a segment, and they want a bisector. If you read number 13, they're looking for a bisector. That means it's going to go split it right in half. So I want to find the midpoint of these 2 points. Remember, in order to find the midpoint, I'm going to take my x1 plus my x2 divided by 2 to get my x, the middle of these 2 points. You're just taking the average of them. You add them up and divide by 2, because there's 2 that you added up. Add them up, divide by 2. There we go. And then I have my y1 plus my y2 to get the middle of those 2 points. And that's going to be 7. So my midpoint is 1, 7. Okay, you can kind of see my arrows. I'm working it down to save space. All right, so here's the point, and here is my slope. So I just do like I did in number 1. Here we go. I'm going to have my point and my slope. So I use my point slope formula. I plug in the slope. I plug in my x1. I subtract 1. And my y1 I add. So I add 7. 3 times x is 3x. 3 times a negative 1 is negative 3. And then I have this plus 7. And so my equation that's going to be perpendicular bisector for this one is, and those points, negative 5, 9, and 7, 5, the line that's going to be the perpendicular bisector of that line segment is going to be y equals 3x plus 4. Okay, hopefully this helps. Looks like you're going to be doing that for number 14 also. So remember, find the line first, figure out what the slope is. Do your slope first for those points in number 14. Figure out what the slope is. And I guess, you really didn't have to do all this. You could just figure out what the slope is. You don't have to do all of this. You don't have to figure out the line that it's on, because that became kind of hectic, because I could have just went from here straight to this to find out what my slope of my equation is going to be. So you don't have to do all this for number 14. I'm sorry, this was number 13. I called it number 11. Okay, so for number 14, you could just skip all this and just figure out what the slope is. And then find the midpoint so that you have a point. And then, get the opposite inverse, because it's going to be perpendicular bisector again. And then use your point and then figure out yours. Okay, that will save you some work. Okay, hopefully this helps. And if you make mistakes, as long as you learn from them, you're making progress.